I'm going to run through an example question about using smoothing. And this is a question from the Maths World textbook, which is published by Macmillan, and it's exercise 3.3. Question 3 in that exercise was to do with mean smoothing, and question 11 followed on and was to do with median smoothing. So the question said this: the production of a particular item in a factory has varied as follows, and we've got some data. First part of the question, smooth the time series using 4-point moving averages with centering. Then plot the original data and the smoothed data on the same axes. Then calculate the equation of the least squares trend line for the smoothed time series data. Then, using the least squares trend line, predict the production in 2007. The next part of the question says, using the same data, smooth the data using 4-point moving medians with centering. Plot the original data and the smooth data on the same axes. Find the equation of a trend line for the smooth data using 3-median regression and least squares regression. And then predict the production in 2007 and compare that with your answer that you got when you were using averages, means for smoothing instead of medians. So here's my table of data. Now the first part of the question wants me to smooth the time series using 4-point moving averages with centering. So let's start with our groups of 4. Here's my first group of 4 from there to there. Now 18, 22, 32 and 36, what's the average? 27. So I'm going to write my 27 right in the middle here, in the middle of those 4. Now the next group of 4 that I'm working on is these 4 here. So I want to know the average of 22, 32, 36 and 40. That's 32.5, which I'm going to write right in the middle here of those 4. My next group of 4 is from there to there. So I want to know the average of 32, 36, 40 and 47. My next group of 4 will be here, and so on. Now I've done as many of the groups of 4 as I can. I'm going to do the centering step, and that involves finding the average of these groups of 2. So average of 27 and 32.5 gives me 29.75. Average of 32.5 and 38.75 is 35.63. I'm just going to do these to 2 decimal places. Now we continue like this for the others, centering these pairs. So there's my smoothed and centered values, and that's part A done. Part B wants me to plot the original data and the smoothed data on the same axes. Here's what that would look like. The green is the original and the red is my new smoothed data. Part C wants me to calculate the equation of the least squares trend line for the smoothed time series data. So what I've entered into my lists to get this graph is this is t equals 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And these were the corresponding y values for the original data. And at t equals 3, I have 29.75. At t equals 4, I had 35.63 and so on. So what I'm going to do is using these 1 to 10 as my x's and these values here as my y's, run a linear regression. So most of you are probably using CAS calculators, but I don't know how to show you one of those on a computer screen. I'm going to use a TI-83. Translate it for how your calculator does this. So I press Stat, Edit, and I get into my lists. In list 1, what I'm going to enter is starting at 3, because this point here, what I'm running the linear regression on, starts at 3. So I have 3 to 9 in the first list, and then these corresponding values. My mistake is actually 1 to 8. I don't need this 9 here. So now I run a linear regression on L1 and L2, and I get y equals 5.5x plus 13.38. So we have y equals 5.51x plus 13.38. For those who have the Maths World textbook, the answer in the back is 13.4. The reason for that is we've rounded to 2 decimal places and they rounded to 1. So, part D of the question said, using the least squares trend line, predict the production in 2007. So if this here was t equals 1, this was t equals 2, 3, 4, 5, 6, 7, 8, 9, and 10, 2006 will be 11, and 2007 will be 12. So what we're trying to do is use this trend line to predict when x, or t, I might just write this as t, will be 12. So I'm going to sub in 12 for that t there. So y equals 5.5 times 12 plus 13.38. And here's a nifty trick for anyone who does actually use a TA 83 or 84 or 89. When you're running your regression, you say stat calc 4 for the linear regression. If we say L1, comma, L2, comma, and then we say Y1, which to get to we press this vars button, and then we go across to Y vars function, so 1, and then you press enter for Y1. So now we've got linreg L1, comma, L2, comma, Y1. Press enter. Still does the linear regression for us, but now stored in the Y1 is the equation of our regression line, so we can graph that really quickly. The other thing that's quite handy is when you're back at your main screen, we can say distribution yvars function y1. We want to evaluate y1 for 12. So you say y1 brackets 12, enter, and it gives you your answer straight off. Now this is slightly different to this because it's more well rounded. So that's the other thing, can be quite handy when you don't want to get any rounding errors. This is calculated to lots and lots of decimal places. Anyway, handy tip. Actually, that just helped me notice a difference here. I've left off one of my digits. If I put my 1 back in there, I actually get 79.5. I was thinking those two, that shouldn't be such a huge rounding error. So 79.5 is the answer I get here, which, going back to the question, we want to know the production in 2007. This is production in thousands, so we're expecting 79,500. Now the next part of the question said, smooth the data using 4-point moving medians with centering. So we're going to start all over again and do it with medians instead. So we start again with that table and we're going to use 4-point moving medians. Let's work out the medians first and then we'll do the centering step. So here's my first group of 4. Now with 18, 22, 32 and 36, which one is the median? In order they go 18, they're already in order. How handy. So the median is going to be between those two. Halfway between 22 and 32 is 27. So here I have a median of 27. Next group of 4 is these ones with 22, 32, 36 and 40. Which one is the median? Oh, they're in order again. How helpful. 34 is my median there. Next group of 4. 32, 36, 40 and 47. Median will be halfway between 36 and 40, which is 38. Next group. Median is going to be halfway between 40 and 47, which is 43.5. And so on for the other groups. So now that I've got my 4-point moving medians, I just need to center those. So centering 27 and 34. Remember, I'm doing 27 plus 34 divided by 2, and I get 30.5. Centering 34 and 38, I'll have halfway between them, which is 36. Centering 38 and 43.5 is 40.75, and so on. Now I have my centered values which correspond to these coordinates for t, or x. Part B of the question wants us to plot the original data and the smooth data on the same axes again. So I'll show you that on the calculator this time. Wake up. So in my lists, I'm now going to have 1, 2, 1 to 10 in L1, my original data in L2, and because on this calculator I can't leave those first two fields blank and just start with L1 versus L3 starting at 3, I'm going to have to enter here 3, 4, 5 and so on in L3 and my smoothed data in L4. And now I'm going to graph those. So second y equals to get to stat plot. My first plot I'm going to turn on and it's going to be a time series plot. The first one I do want to have L1 versus L2. Then I'm going to turn on another stat plot, which will be time series as well. And this one I'm going to have L3 versus L4. Now I press graph and I've still got in my y equals our regression line from the previous part. So going back to graph, zoom, stat, which is 9, and they're both on there, though it's very hard to see. If I change the window so that we're zoomed right in close, you can see that there are actually two lines on there. Here it is again with the different colors so you can see it a bit clearer. The next part of the question wanted us to find the equation of a trend line for the smoothed data using 3-median regression and least squares regression. The easiest way to do the 3-median regression at this point, when you've already got everything entered into your calculator, is to get your calculator to work it out for you. I'm actually going to show you how to do this from a table though, just because I don't think I've shown you this method before, and hey, this is all about showing you how to do stuff. So this is what my table of data looks like. Up here we had t equals 1, t equals 2, 3, 4, 5 and so on. So at t equals 3 I had the point 30.5, at t equals 4 I had 36 and so on. So I've just transposed that into this table down here. Now I'm going to do 3-median regression on this table. What's the first step in 3-median regression? It's splitting it into 3 groups. So I need to find out how many points I have. Well, there's 1, 2, 3, 4, 5, 6. Okay, that's perfectly divisible by 3. I'm going to split them into 3 groups of 2. So there's the first group, and there's the second and third groups. Now I need to find the median vertically and horizontally for each of these coordinates. Here I've got coordinates 3, 30.5, and I've got 4, 36. So if I'm finding the difference between the x's of those going along the horizontal, I'm really just finding halfway between 3 and 4. If you picture it, if they're plotted here and here, say, I'm finding the distance between 3 and 4. Where's the middle horizontally? So that would be here. And then I find the difference vertically. So that's between here at 30.5 and here at 36. So I don't need to have this scatter plot. Halfway between 3 and 4 is 3.5. So that's the x part. That's the x coordinate for my new median point. And halfway between 30.5 and 36 is 33.25. So that's the coordinates of that far left median. Now let's do the one for the center. Halfway between 5 and 6 is 5.5. So that's the horizontal part, that's the x part. And now the vertical. Halfway between 40.75 and 46.25 is 43.5. Now the far right one. Halfway between 7 and 8 gives me 7.5 for the x coordinate, and finding the middle of these two is 54.5. So now I have my 3 median points. From these I can find m. So m is the difference in y over the difference in x using the far left and the far right coordinates. So we have 54.5 minus 33.25 over 7.5 minus 3.5, which is 21.25 over 4, 5.31. So m equals 5.31. I've got the first part of my y equals mx plus c. The next part I need to work out is the c. When we're doing that from a table, we need to use the formula. To use the formula for c, I need to know what all my y's added together are and what all my x's added together are. So what are the y's? They're 54.5 and 43.5 and 33.25. That's these three here I'm adding together, which is 131.25. Now what about all my x's added together? That's 7.5, 5.5 and 3.5, which is 16.5. I've just moved that up to give myself some space. Now the formula for C is a third of all my y's added together minus m times all my x's added together. So let's sub those in. We have C equals a third of all my y's, which was 131.25, minus m, which was 5.31, times all my x's added together, which was 16.5. Using BODMAS, the first part I need to evaluate is this, which is 87.615. And I'm going to take that away from 131.25. So that's 43.635. Now, timesing that by a third or dividing by 3, I get 14.55. So the C is 14.55. Now I can write my regression equation in the form y equals mx plus c. Y equals 5.31x, although this is actually t for this example, plus 14.55. So that's my equation when I use the 3 median method for regression. What about when I'm using least squares? In further maths, we don't teach you to do this out by hand. You just need to use your calculator. So, bringing my calculator back up, in the stat edit, in list 3 and list 4, I already have my data entered, so I'm just going to ask it to run a linear regression on L3 versus L4. Y equals 5.33x, or in this case t, plus 14.44. So those are my two equations. They're quite similar, but each method has come out with a slightly different answer in terms of the rounding. The last part of the question said predict the production in 2007, presumably using both of these equations, and then compare the answers with what we got earlier in the question when we were using moving means instead of moving medians for our smoothing. So what's our t-value for 2007? If this here was 10, then 2006 would be 11, which means 2007 would be 12. So we want to evaluate when t equals 12. So for this equation, which was the 3 median method equation, we have y equals 5.31 times 12 plus 14.55, which gives y equals 78.27. Our production was in thousands, 78,270. Using this equation over here, which was the least squares method of regression, we have y equals 5.33 times 12 plus 14.44, 78.4, or 78,400 units of production. Back in the previous part of the question, using this regression equation, we got an answer of 79,500. So we had 79,500 when we were using the moving averages, moving means for our smoothing. We got 78,400 when we used the least squares method of regression with a moving median smoothed trend line. And over here, let's say we round this to the nearest 100 for simplicity, we had 78,300 when we were using the moving medians with a 3 median regression. So comparing those, you can see they get more conservative each time. We had 79,500, 78,400 and 78,300. So using moving medians, we think about 1,000 units less will be produced than when we used moving averages. And that, in a rather large nutshell, is how to do smoothing on time series data.